purification for 1,700 days.
Disclaimer: the content on this channel is meant only to provide helpful insights, tips, and information on certain subject or topic. While we strive to provide accurate and up-to-date knowledge, this is not a substitute for professional advice. Always consult a qualified expert or professional for your specific needs. We encourage you to use this content as a guide for learning and additional information. If you think this does not fit what you want, please skip the video.
How does a solid turn into a liquid and then vapor? The changes of state from solid to liquid to vapor can be explained through the lens of particle arrangement and energy changes. As matter transitions from one state to another, the arrangement of its particles and the energy associated with their movement changes significantly. Here's a detailed breakdown of each stage. Solid to liquid, also known as melting. Particle arrangement. In a solid, particles are tightly packed in a regular fixed arrangement. The particles vibrate around fixed positions, but they do not move freely. The strong intermolecular forces between particles hold them in place, giving the solid a definite shape and volume. As heat energy is added to the solid, the particles gain kinetic energy and vibrate more vigorously. At the melting point, the particles have enough energy to partially overcome the intermolecular forces holding them in fixed positions. As the solid melts, the particles break out of their rigid structure and start moving past each other, resulting in the more fluid arrangement seen in liquids, though the particles are still relatively close together. Energy changes. Energy is absorbed during melting. The heat energy added is used to overcome the attractive forces between particles, allowing them to move more freely. This absorbed energy is called the latent heat of fusion, which is required to change the solid into a liquid without increasing its temperature during the transition. So, let's talk about how a liquid transforms into vapor. This process can happen through either evaporation or boiling. Essentially, the liquid turns into vapor, moving from one state of matter to another. In a liquid, particles are closer together than in a gas, but not in a fixed arrangement like in a solid. They are free to move around each other, but still experience significant intermolecular attraction, which keeps the liquid together. As more heat energy is added, the particles gain even more kinetic energy. Some particles, particularly at the surface of the liquid, gain enough energy to break completely free from the intermolecular forces, allowing them to escape into the gas phase, or vapor. In the vapor state, particles are spread far apart and move rapidly in random directions with minimal interaction between them. To change from a liquid to a vapor, whether through evaporation or boiling, the substance must absorb a significant amount of heat energy. This energy, called the latent heat of vaporization, is required to break the intermolecular forces completely, allowing particles to escape as gas. During evaporation, this heat is absorbed without a change in temperature until all the liquid has evaporated. Boiling occurs when the liquid reaches its boiling point, and vaporization happens not just at the surface, but throughout the liquid. Large amounts of energy are absorbed at the boiling point to transform the liquid into a gas. Solid to liquid, or melting. Particles move from a rigid, tightly packed structure to a more fluid arrangement where they can slide past each other. Energy is absorbed to overcome the strong intermolecular forces, but the temperature remains constant during the phase change. Liquid to vapor, or evaporation and boiling. Particles move from a fluid arrangement to a random, dispersed state with no fixed position as they move independently in the gas phase. Significant energy is absorbed to break intermolecular forces entirely, allowing particles to escape as gas. Particle arrangement becomes progressively more disordered from solid to liquid to vapor, with particles in solids being closely packed, liquids being loosely packed, and gases being widely dispersed. Energy changes, both phase changes, solid to liquid and liquid to vapor, require energy absorption to break the intermolecular forces between particles. The energy absorbed during these transitions does not raise the temperature, but instead is used to change the state of matter.